Assalamu alaikum everyone. Hello and welcome back to the channel Kashmir Scientist. Hope you all will be doing great and preparing for your exams well. And I also hope कि आपने हमारे इससे पहले वाले जो भी वीडियो है वो अच्छे से देखे होंगे, उनको आपने पसंद भी किया होगा और आगे भी करते रहेंगे इंशाल्लाह. And hope so कि ये लेक्चर्स आपको अच्छे लगेंगे and they will help you crack your board exams as well as आपको अच्छे से कंसेप्ट्स भी देते चले जाएंगे. तो चलो स्टार्ट करते हैं ये वाला लेक्चर जो कि है केमिकल रिएक्शंस एंड इक्वेशंस का. तो पहले जब भी हम इसका नाम ही लेते हैं तो पहला ही जो वर्ड आता है इसमें केमिकल रिएक्शन. तो बेसिकली केमिकल रिएक्शन होती क्या है पहले हमको ये जानना होगा, उसके बाद फिर हम केमिकल इक्वेशंस पे जा सकते हैं. तो केमिकल रिएक्शन होता क्या है? We can say that it is the transformation of chemical substance from one substance into another. एंड होता क्या है कि इसमें जो हमारे पास कोई भी केमिकल सब्सटेंस होता है जिसका हमारे पास केमिकल जो उसका मॉलिक्यूलर लेवल कंपोजिशन है वो हमको पता है. जब उसमें कोई चेंज आ जाती है मॉलिक्यूलर लेवल पे अल्टरेट होता है तो we say that there is the occurrence of chemical reaction. हम कहते हैं कि यहाँ पे केमिकल रिएक्शन हुई है, वहाँ पे ट्रांसफॉर्म होता है वो एक केमिकल सब्सटेंस इनटू अनदर. फॉर एग्जांपल जब हम अपने इर्द गिर्द देखें अपने माहौल में नेबर में तो दिन भर हम बहुत सारी ऐसी एग्जांपल्स है जो हम लेके ये समझ सकते हैं कि केमिकल रिएक्शन होती क्या है. फॉर एग्जांपल अपने घर का ये एग्जांपल ले, जब हम दूध को उबाल के रखते हैं किसके लिए, सो दैट वी कैन कन्वर्ट इट इनटू द कर्ड. दैट इज एक्चुअली केमिकल रिएक्शन बिकॉज when we see the molecular level composition of milk and curd, they are different, and we say that there is the alteration or transformation of one chemical substance into another, and hence that is a chemical reaction. ऐसा ही और एक एग्जांपल ले, फॉर एग्जांपल हमारे घर में इर्द गिर्द जो भी है आयरन होता है, जो भी लोहे के पोल होते हैं या कोई भी घर में ऐसी चीज़ होती है जो लोहे से बनी हुई होती है, तो जब टाइम गुजरता है तो धीरे धीरे 5 महीने 6 महीने के बाद हम उस पर थोड़ा सा वो जंग लगा दिखा होता है. दैट इज़ एक्चुअली ए केमिकल चेंज. उसे हम रस्टिंग ऑफ आयरन कहते हैं. वो आगे हम डिटेल में डिस्कस करेंगे. अभी एग्जाम्पल के तौर पर मैं आपको समझा रहा हूँ कि केमिकल रिएक्शन होती क्या है. ऐसा ही हमारे जिस्म में फॉर एग्जांपल डाइजेशन होती है, रेस्पिरेशन होती है. पहले डाइजेशन के हम जो लेते हैं अंदर वो डाइजेस्ट होता है. दैट इज़ ए केमिकल चेंज, क्योंकि जो हमारा फूड है उसके ऊपर काम करते हैं एंजाइम्स एंड बाकी चीज़ें, तो वो हमारी क्या एक केमिकल चेंज बन जाती है. इसी तरह रेस्पिरेशन, व्हेन द फूड इज़ ब्रोकन डाउन इनटू, जब हम उससे एनर्जी लेते हैं, हमारे बाकी जो भी अंदर प्रोसेसेस होती है उनके लिए जो भी हम उससे एनर्जी लेते हैं, दैट इज़ आल्सो ए केमिकल change. What happens in the chemical change is that a new substance is formed which is completely different in properties. ये वाला वर्ड जो है properties, क्योंकि पहले हम देखते हैं कि जो molecules होते हैं, we can say for example जब हम कार्बन को जलाते हैं in presence of oxygen we get what is called carbon dioxide. इसमें भी ये ऑक्सीजन कार्बन और इसमें भी दोनों प्रेजेंट रहते हैं, लेकिन फिर भी क्या होता है कि इसकी प्रॉपर्टीज चेंज होती है. ये इसी वजह से होता है क्योंकि इसका जो केमिकल कंपोजिशन है वो मॉलिक्यूलर लेवल पे चेंज हुआ होता है. इसीलिए हम कहते हैं कि ये एक केमिकल चेंज है. सो केमिकल चेंज में क्या होता है, केमिकल रिएक्शन में क्या होता है कि एक केमिकल चेंज टेक्स प्लेस, एंड जनरली जो भी केमिकल चेंजेस होती है वो जनरली इरिवर्सिबल होती है, वो वापस नहीं आ सकती. इसी तरह वी कैन से कि एटॉमिक लेवल पे अरेंजमेंट होता है. पहले बॉन्ड्स ब्रेक हो जाते हैं, उसके बाद नए बॉन्ड्स बनते हैं, नए मॉलिक्यूल्स आपस में जुड़ते हैं, तो वो एक केमिकल रिएक्शन कहलाती है. इसी चीज़ को हम केमिकल रिएक्शन कहते हैं. एंड दैट केमिकल रिएक्शन हैज़ 2 पार्ट्स इन इट. जो पहले हमारे पास सबस्टेंस होते हैं, जो भी केमिकल सबस्टेंस हमारे पास है जो पहले हमारे पास होते हैं। एंड these substances we change into another substance on the occurrence of chemical reaction. These substances are called reactants. These are called reactants. They take part in a chemical reaction. These substances are which take part in a chemical reaction are called reactants. इसी तरह हमारे पास जो एंड प्रोडक्ट होता है एक केमिकल रिएक्शन का, जब हमारे पास कुछ केमिकल सब्सटेंसेस मिलके जिनको हम रिएक्टेंट्स कहते हैं, वो मिलके एक केमिकल रिएक्शन जब उन पे होती है तो जो हमारे पास एंड प्रोडक्ट होता है दैट इज कॉल्ड द केमिकल प्रोडक्ट ऑफ द केमिकल रिएक्शन, उसको हम प्रोडक्ट कहते हैं। एग्जाम्पल के तौर पर हमारे पास एक एग्जाम्पल है बर्निंग ऑफ मैग्नीशियम इन एयर टू फॉर्म मैग्नीशियम ऑक्साइड इज एन एग्जाम्पल ऑफ केमिकल रिएक्शन। हमारे पास एक मैग्नीशियम रिबन है Mg, और जब वो ऑक्सीजन के साथ मिलती है, जब वो जलाई जाती है इन प्रेजेंस ऑफ ऑक्सीजन, वहाँ पे हमें एक वाइट कलर्ड पाउडर मिलता है, ये जिसको हम मैग्नीशियम ऑक्साइड कहते हैं। ये क्या है? ये हमारा प्रोडक्ट है, दिस MgO. This is our product, and the set of these two chemical components, oxygen, this is actually O2 and twice Mg. मैग्नीशियम तो सॉलिड फॉर्म में होता है, ये आगे हम पढ़ेंगे कि इस S का मतलब क्या है, G का मतलब क्या है। मैग्नीशियम जब ऑक्सीजन के साथ मिलता है तो हमें क्या? मैग्नीशियम ऑक्साइड मिलता है। ये वाइट कलर्ड होता है और ये पहले हमारे पास रिबन सी होती है, एक सॉलिड मटेरियल होता है, और जब जलाया जाता है तो हमारे पास मैग्नीशियम ऑक्साइड आ जाता है। दिस इज एन एग्जांपल ऑफ केमिकल रिएक्शन वेयर मैग्नीशियम एंड ऑक्सीजन, these two are called reactants and magnesium oxide is our product. And going forward we can see, जब हमारे पास हम देखते हैं कि अब चलो हम मान ले हमने देख लिया कि रिएक्टेंट्स पे जब कोई रिएक्शन होती है तो हमारे पास प्रोडक्ट्स आ जाते हैं, लेकिन हमको कब पता चले कि ये एक केमिकल रिएक्शन है? For that we have some characteristics, we have some properties that we are going to study or see in a chemical reaction so that we can say कि हाँ एक केमिकल रिएक्शन हो गई है। तो उसके लिए पहला जो कैरेक्टरिस्टिक है दैट इज एवोल्यूशन ऑफ गैस। जब भी दो रिएक्टेंट्स आपस में मिलते हैं और एक नया प्रोडक्ट बनाते हैं, नया एक केमिकल सब्सटेंस बनाते हैं, ये कि केमिकल रिएक्शन वहाँ पे हो जाती है, तब अगर वहाँ पे कुछ भी एवोल्यूशन ऑफ गैस हो जाता है, वहाँ पे गैस कोई रिलीज हो जाती है, तो बाय दिस एवोल्यूशन ऑफ गैस वी कैन से दैट द केमिकल रिएक्शन हैज ऑकर्ड। फॉर एग्जाम्पल हमारे पास जो जिंक है, जिंक ग्रेन्यूल्स होते हैं बेसिकली, उसके साथ जब हम सल्फ्यूरिक एसिड का ये इन दोनों को आपस में रिएक्शन करवाते हैं तो हमारे पास जिंक सल्फेट ये आ जाता है और वहाँ पे हाइड्रोजन गैस रिलीज हो जाता है जो हवा में उड़ जाता है। एंड दिस एवोल्यूशन ऑफ गैस, बाय दिस एवोल्यूशन ऑफ गैस वी से दैट द केमिकल रिएक्शन हैज ऑकर्ड। ऐसे ही बहुत सारी, फॉर एग्जांपल कार्बन को जब हम ऑक्सीजन के साथ बर्न कराते हैं तो वहाँ पे कार्बन डाइऑक्साइड गैस निकलती है, and by this we can say that the chemical reaction has occurred, chemical change has occurred. Similarly, the second property, that is the change in color. When there is change of color, when the reaction occurs between two reactants and the product changes its color, when the product is formed there is change in color, we can say that the change has occurred. For example, when the chemical reaction between citric acid and purple colored potassium permanganate, that is basically, firstly that is purple, solution is characterized by change in color from purple to colorless. जब हम साइट्रिक एसिड और पर्पल कलर्ड पोटेशियम परमैंगनेट, साइट्रिक एसिड और पोटेशियम परमैंगनेट के बीच में जब रिएक्शन होती है तो पहले हमारे पास जो पोटेशियम परमैंगनेट होता है वो पर्पल होता है, लेकिन जब इन दोनों के बीच में रिएक्शन हो जाती है तो वहाँ पे एक कलरलेस प्रोडक्ट आता है हमारे पास, एंड दिस कलरलेस प्रोडक्ट, दिस कलरलेसनेस से हमको पता चलता है कि हाँ एक केमिकल चेंज और एक केमिकल रिएक्शन हैज occurred. Similarly, the chemical reaction between sulfur dioxide gas and acidified potassium dichromate. जब सल्फर डाइऑक्साइड और पोटेशियम डाइक्रोमेट K2Cr2O7 के बीच में एक रिएक्शन होती है तो वहां पे चेंज इन कलर होता है। कहाँ से? पहले पोटेशियम ये जो है पोटेशियम डाइक्रोमेट, इट इज ऑरेंज कलर्ड कंपाउंड, and when this reacts with sulfur dioxide we get a color of green from what? Orange. And this green color, when we got this green color, we say that there is chemical change or chemical reaction has happened between the two substances, that are sulfur dioxide and potassium dichromate. These are two properties. First is evolution of gas, second is change in color, and the third, that is change in the state of a substance. Till now we study two. First was change, evolution of gas. Second was what? Change in color. These were the two properties. And now the third property by which, or the characteristic by which we can say that the change has occurred, that is the change in the state of the substance. जब जो हमारे पास रिएक्टेंट्स है, जब वो आपस में मिलते हैं, जब उनमें एक चेंज हो जाती है, केमिकल रिएक्शन टेक्स प्लेस, देयर इज चेंज इन स्टेट. फॉर एग्जांपल हमारे पास कोई सबस्टेंस है, दैट इज फर्स्टली व्हेन दैट इज इन द रिएक्टेंट स्टेट इट इज इन सॉलिड फॉर्म, और फॉर एग्जांपल से गैसवस फॉर्म में, और एक्वस और लिक्विड फॉर्म. ये हमारी फॉर्म्स है जिनमें हमारे पास क्या रिएक्टेंट्स होते हैं. तो जब यहाँ से रिएक्शन हो जाती है तो हमारे पास फॉर एग्जांपल सॉलिड है तो एंड प्रोडक्ट आके एक्वस फॉर्म में आ जाता है, गैस है तो हमारे पास ये सॉलिड फॉर्म में आ जाता है फॉर एग्जांपल. तो हम कहते हैं कि हाँ देयर इज ए केमिकल रिएक्शन. फॉर एग्जांपल द कंबशन रिएक्शन ऑफ कैंडल वैक्स, जो हमारे पास सिंपल सी मोमबत्ती होती है घर में, जब उसमें क्या होता है, जब वो जलता है तो पहले वो किस फॉर्म में होता है, दैट इज इन सॉलिड फॉर्म, पर जब वो जलता है तो वो किस में हो जाता है, सॉलिड टू लिक्विड चेंज हो जाता है, एंड देयर इज गैस बिकॉज द वैक्स इज सॉलिड. Water formed by the combustion of wax is at liquid at room temperature, whereas carbon dioxide produced by the combustion of wax is gas. तो यहाँ पे हमें दो दो चेंज इन स्टेट मिलते हैं. पहले सॉलिड से किस में, लिक्विड में, जो क्या है, दैट इज वाटर फ्रॉम द वैक्स, क्योंकि सॉलिड जब पिघलता है तो वहां से जो वाटर कंस्टिट्यूएंट है उसका वो निकल जाता है, एंड दैट इज इन द फॉर्म ऑफ लिक्विड, क्योंकि वो रूम टेम्परेचर पे लिक्विड होता है. एंड सेकंड इज जो वहां पे कार्बन कंपोनेंट है, उसका कार्बन कंपोजिशन है किसका, सॉलिड वैक्स का. तो वो जब ऑक्सीजन के साथ मिलता है तो वहां पे कार्बन डाइऑक्साइड देता है, जो रूम टेम्परेचर पे क्या होता है, दैट इज गैस. By this reaction or by this example we can say that there is chemical change. So this was the third characteristic, and what was it, change in the state of a substance. There are some chemical reactions which can show more than one characteristic. As in the example above, we saw that there is change in state, and that not single change in state, but we saw there are multiple changes from solid to liquid as well as solid to gas. और जब हमने वहाँ किस में देखा, दूसरी एग्जांपल हम लेंगे, कार्बन फॉर एग्जांपल सॉलिड फॉर्म में है, हमारे पास कोल है या कोई भी एनीथिंग अदर जो लकड़ी वकड़ी होती है दैट कंटेन्स कार्बन, तो वो हमारे पास सॉलिड फॉर्म में है. तो हमें उसके बाद मिलता है, जब वो कंबशन करता है ऑक्सीजन के साथ तो कार्बन डाइऑक्साइड मिलता है, बट दैट इज इन द gaseous form. So we can say that there is change in substance, change in state of the substance from reactant to product side, and we can say by this characteristic too that the chemical reaction has occurred. Similarly, the fourth characteristic is change in the temperature. Change in the temperature. The chemical reaction between quick lime water to form slaked lime is characterized by change in temperature. तो हमारे पास जो कैल्शियम CaO plus H2O, CaO is called what? Quick lime. This is called quick lime, calcium oxide. तो इन दोनों के बीच में जब रिएक्शन होती है we get CaOH, this CaOH2. What? CaOH2. This, when this reaction occurs, there is change in temperature, which is rise in temperature. इन दोनों के बीच में जब रिएक्शन होती है and the tub or the bath in which this reaction takes place, or test tube or anything other in which we have placed the reactants, and when the product is formed, there is increase in temperature. What? There is increase in temperature, and this rise in temperature gives us, this acts as a characteristic, or we can say as a property, to show that there is change or chemical change and a chemical reaction has occurred. This was the fourth property or the characteristics by which we can say that the chemical change has occurred. And there is one more example. For example, when the zinc granules and dilute sulfuric acid is also characterized by change in temperature. तो जब जिंक ग्रेन्यूल्स और सल्फ्यूरिक एसिड के बीच में रिएक्शन होती है, जिंक एंड सल्फ्यूरिक एसिड H2SO4, इन दोनों के बीच में जब रिएक्शन होती है, जो हमारे पास प्रोडक्ट आता है उसमें भी टेम्परेचर राइज होता है. क्या होता है? टेम्परेचर राइज होता है. एंड दिस रिएक्शन also, where there is rise in temperature, this also tells us that this is a chemical reaction. And the fifth property, the fifth characteristic is formation of precipitate. Precipitate, we can say, is type of a solid material that settles down after the reaction. In the aqueous form, it settles down at the bottom, and we say that the chemical reaction has occurred. For example, when there is a reaction between sulfuric acid and barium chloride, sulfuric acid and barium chloride, we get barium sulfate and HCl, hydrochloric acid. We get what? Barium sulfate and hydrochloric acid. Barium chloride is actually in what form? It is in aqueous form. And sulfuric acid is also in aqueous form. But the products here are, look, here we have too many properties, or we can say 2-3 properties that we account in this reaction. First is change of state. Here the reactants were in aqueous state, but we got what? Barium sulfate as a precipitate in the solid state. This is one characteristic by which we can say that the change has occurred. Similarly, the second is the formation of precipitate, because this precipitate settles down in the aqueous solution of hydrochloric acid. That says us that the chemical reaction has occurred. This barium sulfate is what? This is a solid substance that settles down and at the bottom of the flask in which we have taken the reaction, and it settles down at the bottom, and we see that the chemical reaction has occurred. These were the 5 properties or 5 characteristics by which we can say that the chemical reaction is happening or has occurred. First is what? The change of state. First was change of state from solid, liquid, gas to any other, or from solid to liquid, from solid to gas, or liquid to solid, and so on. That was the first characteristic. Second was what? Evolution of gas. Evolution of gas. And the third was what? Rise in temperature. Rise in temperature. And the fourth was what? Formation of precipitate. Formation of precipitate. And one more was there, that was what? Change of state, evolution of gas, rise in temperature, formation of precipitate, and one other is change in color. Change in color. These are the 5 characteristics that we need to know to actually summarize or say about a reaction that the reaction has, say about a change that the chemical reaction has occurred. These are the 5 parameters on which we can say that the change has occurred. Now we know what a chemical reaction is. What a chemical reaction is? It is a chemical change or a transformation of one chemical substance into another. And these chemical changes are characterized by these 5 set of 5 properties by which we can say that the change has occurred. Now moving on to what are chemical equations. As we already know now that what are chemical reactions. So chemical equations are what? When we see the word, this word equation, it is related to what? Equality. And we know already what? Chemical reactions has 2 parts, that is reactants and products. That we know from the previous slides. So these 2 reactants and products, these 2 parts have what? An equality between 2, because what we say in a chemical reaction, that is a transformation. One substance changes into another. One substance changes into another. First of all, in reactants, there is breaking of bonds, and the products, new bonds are formed between the molecules or the atoms, and new substances are formed, which we call as products. But what are the chemical equivalents? They remain the same. They remain same at the atomic level. No? So there is an equality. The number of we can say chemical atoms in reactants and products, they need to be same and conserve the law of conservation of mass. So what is chemical equation now? It is actually the representation of the chemical reaction using symbols and formula of the substance, and that we call as what? Chemical equation. What is it now? It is representation of a chemical reaction. So we have what? A set of reactants and set of products. Set of reactants and set of products. And these set of reactants and set of products, these are differentiated, or there is an, we can't say differentiated, but there is an arrow from reactant side to product side. So we can say these reactants have changed to what? These have changed to products. For example, in this example, A plus B gives us C plus D. In this equation, what? A and B are called reactants, and we are already familiar with what are reactants. Reactants are the starting chemical substances from which we get the products after there is a change or alteration in the reactant side. And these are called what? A and B are called reactants, and C and D, what we get the new substances, these are called products. And there is an arrow. The arrow shows the direction of a chemical reaction. A plus B, arrow to the right side, C plus D. That means these A and B gives us what? After the reaction, they gives us C and D. Condition is if any is written generally above the arrow. What the condition? For example, we may be taking this reaction at some temperature T is equal to 300 Kelvin, or some pressure, or anything else, or room temperature and anything. These are the conditions that we specify on this arrow. This arrow should have been long in order to specify the conditions. For example, I have a temperature of 300 Kelvin on which a reactant A plus B gives us some product, that is C. And these are the conditions, and these are specified basically on wire. These are specified written above the what? This arrow that separates what? The reactant side and the product side. For example, let us take a simple example and show how to represent a chemical reaction. For example, there is a reaction between hydrogen. Hydrogen when reacts with oxygen, we get what? Water. Water. Hydrogen plus oxygen gives us water. But this is cumbersome process to write hydrogen HYDROGEN plus oxygen and water as this. This takes some time. But already we have seen so many times, might have seen, but we were not aware of this fact till now, that we always try to keep it simple. So we have some formulas. And these formulas represent us what are the chemical reactants and what are its products. In this example, we have hydrogen, oxygen, and that gives us what? That gives us what? This H2O. This is the short form, or we can say this is the representation of what? A chemical reaction, in which we just write the formula of the substances that take place in the reaction. And this is actually what? This is a representation. In the first equation, words are used. जैसा कि आपने पिछली वाली स्लाइड में देखा कि हमने क्या लिखा था, HYDROGEN हाइड्रोजन plus oxygen, and that gave us what? Water. This is called word equation. In second, symbols of the substances are used. As we know from the periodic table that we have symbol H for what? H for hydrogen. Similarly, O for oxygen, and so on. We need to remember the symbols for every element in order to represent it in a chemical equation. So the symbols of the substance is used to represent a chemical equation. As we can see in the previous slide, we saw that hydrogen and oxygen, they are replaced by their symbols. Hydrogen is replaced by H2 in its molecular form, and oxygen, that too in that exists as dimolecule, diatom, and water that has a chemical formula of H2 and O. So what we have done is we have taken the symbols of these substances in order to represent the chemical reaction in shorthand. So a chemical equation is a way to represent a chemical reaction in concise and informative way. Concise, we got the point because we are writing the symbols right now. But how is it going to be informative? We are trying to shorten it, and still we say that will be informative in an informative way. As we saw, the reaction between H2 plus O2 gives us what? Water. From this equation, what we can infer is this is H2, this is hydrogen, this is oxygen, and what we got is water. But there is no more information written on it. But in previous slide, I told you that this arrow is used to specify the conditions, whether above or below. We specify the temperature, pressure, the conditions in which this reaction has taken place, or the ways and the laboratory conditions, we can say they are specified. And we say that the information is added by specifying the state. For example, this H2 is a gas, oxygen 2 is a gas, and this is a liquid. These are short forms: G for gas, solid, S for solid. And we have AQ for aqueous solutions. aqueous solutions, and L for liquid. And we add these short symbols for the state of a substance in what? In a chemical equation, to make it more informative and specify also the conditions. And that way we can say that now the chemical reaction is what this chemical equation we have make it the simplest way to represent a chemical reaction is concise and informative. Information, what type of information is added? It is actually the state of the substance. What is the state, whether it is solid, whether it is liquid, or whether it is gas. And the conditions, the temperature, the pressure, laboratory conditions, at what temperature, and we can specify time too for some reactions. These are what the conditions that make a chemical equation more informative. Now coming to types of the equations. Equations can be of two types. First is balanced and second is unbalanced. As the name suggests, what is balanced? When let's take example of a weighing balance. We say the weighing balance is balanced, that has two parts. Right now, one part has weights on it and second in which we take the substance that we want to weigh. And when they come at the same point, we say that it is now balanced. Same is the case here. You can take that example to understand it well. Same is the case here. We have two parts in a chemical reaction, chemical equation. First is reactant part, then there is an arrow, and then we have products. You just take the example that these are the two parts of the weighing balance, the reactants part and the products part. Now these two parts will be balanced if this way and this way, if both are equal. And when will the both will be equal? They both will be equal when we have the same amount here and here on the reactant side and the product side. But how can we specify the weight? That is the problem. Now that is not the problem, but the question arises, how can we specify the weight of reactants and products? We can't take 10 ml and or 10 gram or so. We specify the formula, molecular formula, and use symbols. Just like the example above, hydrogen plus oxygen gives us H2O. Look at this example. We have two hydrogen atoms, two oxygen atoms, but here in the product side we have two hydrogen atoms, but there is only one oxygen atom. So this equation is not yet balanced because the oxygen atoms are more on the reactant side than the product side. Now if we multiply the product side by 2, we get what? 2 into 2, that is 4 hydrogen atoms, but we have 2 only. But we have balanced the oxygen atoms because we got 2 oxygen atoms and 2 oxygen atoms on both sides. So what we need to do, we will multiply this H2 by 2. What we got now? 2 times 2, that is 4 hydrogen atoms, and here we got 4 hydrogen, that is actually like this. Take this in a bracket. You can say here twice H2O. Now 2 times 2, that is 4 hydrogen atoms. Same is the case here, and 2 oxygen atoms. Now we can say this equation is what? This is balanced. This type of equation in which there is equal number of atoms on both sides of the equation, reactant side as well as the product side, we say that it is a balanced chemical equation. And what is unbalanced? As the name suggests, now we know what is balanced. So unbalanced is that type of equation in which we don't have the same amount of or same number of atoms on the both sides. As I explained here already, I told you what is balanced and unbalanced. Balanced chemical equation should have been same number of atoms of each element equal on both sides. Balanced chemical equation must have same number of atoms of each element. हर कोई जो भी element है दोनों side, on reactant side as well as the product side, they should be equal in number. Look at this example. We have got one zinc atom here, two hydrogen atoms here, one sulfur atom, and four oxygen atoms. So actually, this is a writing error, H2SO4. Sorry for that inconvenience, but hope so कि आपको समझ आ रहा होगा. This is like that, in which we have got one zinc here, two hydrogen here, one sulfur, and four oxygen atoms on both sides. Hence, what can we conclude from this equation? That it is what? It is balanced. Similar, in this equation, number of zinc, hydrogen, sulfate are equal on both sides, so it is a balanced chemical equation. As already seen, this is what? A balanced chemical equation. According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. That we are listening from a while now. तो हम ये बहुत अब टाइम से सुनते आ रहे हैं कि mass can neither be created nor destroyed. The mass remains constant throughout a chemical reaction. This is what we call what? Law of conservation of mass. In order to obey this law of conservation of mass, the total sum or the total mass on reactant side must be equal to total sum of mass on the product side. And when the reactant side mass and the product side mass is equal, we say that the law of conservation of mass is obeyed. And we say that the chemical reaction is what? This is balanced chemical reaction. So what actually is it following? It is following the law of conservation of mass. Hope कि आपको समझ आ गया होगा what is balanced equation. Now आगे हम थोड़ा इस पे और डिस्कस करने वाले हैं, लेकिन अभी के लिए आप इतना समझ लीजिए कि when there is same number of atoms on both sides, when the reactant side and product side, what we have? Same number of atoms. Same number of atoms. बस ये याद रखना. Same number of atoms on both sides, on reactant side as well as the product side. And we say that the chemical equation is balanced. And what actually is it following? It is following the law of conservation of mass. Law of conservation of mass. That is, mass can neither be created nor destroyed. And coming to the second type, that is unbalanced chemical equations. Unbalanced chemical equation. If the number of atoms of each element, look at the word each element, because we have to take care of all the elements, not only one. We say H2 is balanced here and we infer that this is balanced. No, we have to look at each element in the reactant side. If that is not equal to what? Number of atoms of that element on the product side, what we conclude is that the chemical reaction is unbalanced chemical equation. This is what? Unbalanced chemical equation. Look at the example here. We have Fe, iron, and when this reacts with water, we get Fe3O4. This is like this. Already I told you, Fe3O4 plus H2 plus H2. When we look at this example, we see that we have got only one atom of iron on reactant side, but on the product side we have got three of it. Even though the H2, the hydrogen atoms are balanced here, because we have got H2 here as well as on the product side, we can't say that this equation is balanced because the iron atoms are not balanced in this equation. As explained below, number of atoms of elements are not equal on two sides. But on the left hand side, only one iron atom is present, while there are three atoms on the right hand side. So what we conclude that this is unbalanced chemical equation. अगर हम इसको बैलेंस्ड मानते तो यहाँ पे हमारे पास 3 एटम्स होने चाहिए थे, बट वो है नहीं। तो इसीलिए हम क्या कह रहे हैं कि दिस इज एन अनबैलेंस्ड केमिकल इक्वेशन। तो अनबैलेंस्ड के लिए क्या याद रखना है कि each element number of atoms of each element is not same or equal on both sides, and when these are not equal on both sides, we say that this is an unbalanced chemical equation. तो अभी तक हमने पढ़ा कि 2 types of chemical equations होते क्या है। पहला पढ़ा balanced and second was what? Unbalanced. In balanced, what is followed? Law of conservation of mass. This is LCM, law of conservation of mass, not least common multiple. Law of conservation of mass. And in unbalanced, this is not followed. And the number of atoms are equal on both sides in a balanced chemical equation, but in unbalanced, they are not equal. Now the question arises, how to balance a chemical equation when we are given what? Unbalanced chemical equation. When we are given unbalanced chemical equation, as we encountered one in last section, we got what? Iron plus water, that gives us ferrous Fe3O4 and H2 gas, but this equation was not balanced. So now the question arises, how to balance it. For that we have 1-2 methods, but we will be taking the hit and trial method, that is called. What we do is we take these formulas in brackets so that we will not change its composition. We will take this in brackets. That is, whatever is inside this brackets, we cannot change that. For example, this 3, 4, 2, that will remain as it is. And we can just multiply some coefficients to it so that these get balanced. For example, we can write the names of each individual element. For example, we have got iron here, hydrogen as well as oxygen. These are the 3 types of elements that are present in the reactants and the product side. Now, what are the number of atoms in reactant side and product side? We will do just like make this column in order to understand. When we understand this, then we need not construct these columns anymore. We can do this by just hit and try. But first of all, in order to understand this well, we have to make this separately. For example, we have got iron, hydrogen as well as oxygen, and we specify the number of atoms on the reactant side as well as the product side. Now on the reactant side we have 1 hydrogen atom, this iron atom, but on the product side we have 3. Similarly, we have 2 hydrogen atoms on reactant side as well as product side, means this is balanced. But we have only 1 oxygen atom on reactant side and 4 atoms on product side. Now what will we do? In order to balance this equation, balance the atoms which is maximum in number on either side of the chemical equation. These are the rules that we need to take care of while balancing a chemical equation. So what we need to do first, which is maximum in number on either side, that can be on reactant side or product side. But what we have to see is that has to be maximum. Whether it is on reactant side or product side, that is not the problem. We need to just look at what is maximum. In our example, what we have 4 atoms of oxygen. That is the maximum one that we will be taking. In this equation, the number of oxygen atom is maximum on our right hand side. That is on the product side. We have 4 what? Oxygen atoms. To balance oxygen, one need to multiply oxygen on the left hand side by 4 so that the number of oxygen atoms becomes equal on both sides. So we just multiply here. This is oxygen, this is single atom. We multiply this equation, taking this in bracket. We multiply this equation in this formula by 4. And now we have balanced what? Oxygen atoms. Now the number of hydrogen atoms becomes 8 on left hand side. 4, 2, that is 8. We have now what? 8 hydrogen atoms. But we have only what? 2 hydrogen atoms on reactant side. So what we will be doing? We will need to, because that is the maximum number now, we will be multiplying this H2 by what? This H2 will be multiplied by 4. When this is multiplied by 4, we got what? This hydrogen atom is now balanced. After that, the number of oxygen and hydrogen atom becomes equal on both sides. Now we have balanced two types of atoms, hydrogen as well as oxygen. Now what remains is what? That is this iron atoms. We have got what? How many? We have got 3 iron atoms on right hand side on the product side. And in order to balance this, we will be multiplying this iron, this symbol by 3. And what we get finally is our balanced chemical equation. Because we have balanced all the 3 types of atoms, iron as well as oxygen and this oxygen, hydrogen as well as iron. So we got this equation, that is 3 times Fe plus 4 times H2O gives us Fe3O4 plus 4 times H2. Now looking at this equation, is this balanced or not? 3 iron atoms on left, 3 iron atoms on right. 4 into 2, that is 8 hydrogen atoms on left, and 4 into 2, that is 8 hydrogen atoms on right. 4 into that we can call as 1. 4 into 1, that is 4 oxygen atoms on left and 4 oxygen atoms on right. So we can conclude that this is now what is called balanced chemical equation. Now we got how to balance the equation. First we need to specify, or we need to see what is the maximum number on either side, and we will be taking that firstly, and we will be balancing that part first, and then going on to next element that has got maximum, that might increase, as in this example we got 8 hydrogen atoms, so we have to take that maximum only. And now the balanced equation is what we wrote earlier. This is, and writing the same as formula or name, iron, or we could have written only Fe, similarly H2 or O2, writing symbols only. And the number of atoms, now looking at it in this equation, we see that this is balanced now. Hydrogen are 8 on both sides, oxygen are 4 on both sides, and hence this equation that we got is following what? Law of conservation. Of conservation of mass. And this has become what? This is now balanced chemical equation. And as we learned earlier, how to make the equation more informative, as in the definition itself of what? Chemical equation, we specified that it is most concise and informative. So how we are going to add more information to a chemical reaction? That is by writing the symbols of the physical states of a substance in chemical equation. That is the first way by which we can make it more informative, because when we simply write the chemical equation, we just write the symbols of the elements that are taking part in the chemical reaction, and there is arrow between reactant and product side, and that is it. Now, in order to make that more informative, we specify what are the physical status of the chemical substances, both on the reactant side as well as the product side. And by writing the physical status of substances, a chemical equation becomes more informative. That is the way we can make it more informative. And as I told you earlier, G will be the symbol for gaseous state, L will be the symbol for liquid state, and S will be the symbol for what? Solid state. And aqueous solution is written as AQ. This is the way to specify that this substance is in aqueous form. And this is the first way by which we can make it more informative. And second thing is writing the conditions in which the reaction takes place. And this was already told to you in the earlier slides as well, but repeating again won't take much time. And writing the conditions in which the reaction takes place. The laboratory condition is mainly because we won't be taking these reactions at home. For that, we need to have that setups and the substances as well. So, and it is better to, we can say, take these reactions from reactant to product side in the presence of a supervisor, so that we didn't make any untoward incident happen. Because we can't say believe, we have to learn things, and in learning process we didn't want ourselves to get hurt, because we have to take care of acids as well as many things in the laboratory as well. So always try to do these reactions, do experiments, but in presence of supervisors as well. The condition is generally written above or below the arrow of a chemical equation. So now we have written equation for any of the reaction. For example, taking the same basic example of H2 plus O2, again on what gives us H2O. We say that this is gaseous, this is gaseous, and water is liquid. At room temperature, if we take this temperature to be 25 degrees Celsius, we say that this is room temperature, or NTP, normal temperature. By this way, we have specified the conditions on the arrow, and we have specified what? The status of substance in the equation in order to make this more informative. So till now we have learned what a chemical reaction is, what are reactants as well as products. Then we moved on to chemical equations and the types of chemical equations that were balanced and unbalanced, and balancing unbalanced type of equations, and how to make these more informative. These I hope कि आपको ये सारे जो टॉपिक्स हैं वो समझ आ गए होंगे. And if you have any problem, if you feel any problem, or you want to suggest anything new, or I have mistaken anything, so please feel free to comment below. And anything you need to मतलब आप हमें कुछ सजेशन देना चाहते हैं या कुछ भी फीडबैक दे, उसके लिए आप कमेंट नीचे कर सकते हैं. एंड अभी के लिए आज तक के इस लेक्चर में इतना ही. आगे मिलेंगे इसके सेकंड पार्ट में, जिसमें व्हाट वी विल बी डिस्कसिंग द टाइप्स बेसिकली, and types of chemical reactions. That is will be the second part, and the daily phenomena that we see around us, in which there is concept of chemical reactions. That will be our next video. Kindly subscribe our channel and like the video if you अगर आपको अच्छा लगे कि ये वीडियो अच्छा है. And by clicking the subscribe you will get more notifications about our new videos, और आपके लिए अच्छा कंटेंट आगे लाते रहेंगे. थैंक यू.